add and subtract polynomials. A polynomial looks like this example here on the screen. It's an algebraic expression with many terms. Poly means many. There are some specific terms. If there's only one term in the polynomial, it's called a monomial. If there's two terms in the polynomial, it's a binomial, and three terms is a trinomial. So the one shown here has three terms, as you can see. To add polynomials together, we just add any like terms. But do you remember what it means to be a like term? Like terms are terms whose variables and their exponents are the same. In other words, they're terms that are literally like each other. For example, 2x and negative 3x are like terms because they both have a plane x. However, 2x squared and negative 5x are not like terms because this one has an exponent of 2, while this x is just plain or has an exponent of 1 that we're not actually seeing. So like terms have to have the same variable, and that variable has to have the same exponent. So there's two ways that you can organize adding or subtracting like terms. And I'm going to show you both ways, but it's best if you stick with the one that you like the best. So the example here says to add these. And when we're adding, we can just make a big string of terms. We're adding, so we'll have plus in between these two polynomials. So what I want to do is mark the items that are like. And I can do that by circling or underlining and showing different ways of which ones match up. This one has an x squared and this one has an x squared, so those are like terms. This one has a plain x and so does this. Notice I'm underlining the sign in front of the number with it. And I also have two plain numbers here. Now, not everything will always match up, but I'm just going to make a little, just anything different. Add the ones that are like. 2x squared plus 3x squared is 5x squared. Positive 6x minus 2x is plus 4x. And positive 5 and negative 1 is positive 4. So this is your answer in simplest form. Another way you can do this is to list out the first polynomial and then underneath line up the like terms where they belong. Now they won't always be in order, and if they don't match up with anything in the first line, put it out here on the edge, because in this case it does match up, but it won't always. So the one with the x squared goes under the other one with the x squared. The one with the plain x goes under the other one with the plain x, and the plain number, which is called a constant, goes under the other plain number. And now we just add straight down. So visually, this is a little easier to see what's going on. Be careful with your signs. And of course, you get the same answer. But for some of you, you'll like the way it lines up in columns. Subtracting polynomials works a little bit differently, only because you have to remember what subtracting really means when we're talking about integers, positive and negative numbers. Subtracting means adding the opposite. That's important for you to remember, memorize it, but also to understand it. So the first thing we're going to do for a subtraction problem, when the minus is followed by parentheses, is to change that main minus to plus, and then we're going to change the sign, do the opposite of everything that follows in those parentheses. And then we can go back and use either method we like for adding, because now it's an addition problem. Let me show you what I mean. So if we do the first method, we have 5y squared plus 2xy minus 9. Now I'm going to change this to addition, but to get rid of those other parentheses, I have to do the opposite. Subtraction means adding the opposite. So instead of 2y squared, I'm going to have a negative 2y squared. And instead of plus 2xy, minus 2xy. And instead of minus 3, plus 3. What we're really doing is distributing a negative 1 to everything over here. And so I like to just think of subtracting as adding the opposite. It changes all the signs of everything, only the stuff that follows that subtraction, not the stuff in the beginning. So we have some like terms. And we can add them together and get 3y squared. Notice that negative 2xy and a positive 2xy add up to 0. We don't write plus 0. It doesn't have any effect. Those cancel each other out because they add to 0. And we have our final answer. On the right, I've shown you how the same problem can be done vertically. Before you try some on your own, I want you to look at this page and decide which ones are subtraction problems. Remember, we're looking at the main part, the main adding or subtracting before the second set of parentheses. We don't care whether there's a minus anywhere else. So to have to deal with a subtraction problem by adding the opposite, you're going to do that in number 1 because of that minus followed by parentheses. In number 4 because of that minus followed by parentheses. And in number 5, again, because of the minus followed by parentheses. You can use either method you like once you change subtraction to adding the opposite. Go ahead and try these now. Pause the video and come back when you're ready to check your work. All right, there's a few things I want you to notice here. First, I did the first 4 problems vertically. So I took that second set of parentheses and I moved it underneath the like terms. If it was a subtraction problem, like in number 1 and number 4, I changed it to adding and I wrote in the opposite of each one of these that follows that main minus sign. All right, so this became positive and I just added. I lined everything up. So like in number 2, when I went to add 2a squared, I wrote it underneath the other a squared term. And I wrote that negative 3a underneath the other plain a term. Always take the sign in front of the number with the number, and then you'll never have a sign problem. For number 3, the thing to remember is that when there's not a coefficient written, it doesn't mean it's a 0, it means it's a 1. Remember that a number in front of a letter is actually being multiplied, and so multiplying by 1 doesn't change the value of the term, but it does give us something to add or subtract when we're combining them. When you combine like terms, you just add the coefficients, the numbers in front of the variables. You don't change the variable itself. 4 was a subtraction problem. We added the opposite of everything in the parentheses that followed. Notice that that negative 8 did not have a like term to line up underneath. So I just put it out here at the end, and I had to account for everything in the answer. Whether it had a like term or not, it was included in my final result. Numbers 5 and 6, I did horizontally, where I wrote it out, changed subtraction to adding the opposite of everything in the parentheses that followed, circled my like terms, or circled and underlined in the case of number 6, and then combined. And so the first one, the answer here follows the equal sign, and in number 6, the 8n squared and the negative 8n squared added up to 0. So they canceled each other out because plus 0 doesn't make sense to write. And the only thing left was 4n to the power of 3. Remember, when we're adding and subtracting polynomials, we are simplifying these expressions. There is no way for us to know what the value of n or a or x is. All you're doing is making it simpler, shorter, putting things together that are like. This will take some practice, and some of you have done more of this in the past than others. Remember that we simplify by combining like terms when they exist. Like terms will have the same variables with the same exponents, but the coefficients, the numbers in front, can be different. Terms are separated by plus or minus. A polynomial has many terms. Poly is many. Monomial, 1 term. Binomial, 2 terms. Trinomial, 3 terms. And we just use the general word polynomial for any number of terms. When we subtract, it really tells us to add the opposite. And when subtraction occurs before parentheses, we have to distribute the negative. It's like distributing a negative 1 multiplied to everything that follows. The effect is adding the opposite of every term that follows in the parentheses.